Hello and welcome. We're nearing the end of the project. In this video, our goal is to add a win condition and to show the user an alert. By the end of this video, you will have added a timer to this game and the ability to detect if the user has won or not by the end of the timer. All right, so let's get started. So the first thing we're going to want to do is to add a label to our view so that the user can actually see how much time is remaining. Now I want to add it right on top of the collection view there. So looking at the document outline, we have that guy right here. The first thing I'm going to want to do is actually add that element, and then I'm going to use a vertical stack view to arrange the label on top of the collection view. So open up your object library by hitting Command-Shift-L or hitting this icon up here. In Xcode 10, it's going to look slightly different, but it's still up here. And now I'm going to drag a label and put it actually into the document outline right above the collection view like that. And I'm going to go ahead, hold down Shift and select them both. And I'm going to hit this button here, Embed In. I'm going to choose Stack View. Now when you do this, it's going to take those elements you've highlighted and put it into a stack view. Hopefully Xcode will put it into a vertical stack view, and it looks like it has. But if your stack view ends up to be horizontal, just change the axis property to vertical. You can see that there are some errors now because what's happened is that when we've added these elements into the stack view, it's gotten rid of the auto layout constraints for those elements, namely our collection view. Because our old auto layout constraints for the collection view was relating the sides of the collection view element to the sides of the root view. In this situation now, the stack view is what's on the root view, and the collection view is inside the stack view. So that auto layout constraint doesn't apply anymore. So the first thing I want you to notice is that it's basically thrown the elements into my stack view in not the order that I want. The label is below the collection view, so I'm just going to rearrange it by dragging my label on top. Then I'm going to add a little bit of spacing between the two elements by setting the spacing property to 10 on my stack view. And then what's more, I'm going to add some constraints to the stack view because this guy, we haven't exactly specified the auto layout constraints for it yet. So highlight it, hit this button to add new constraints, check constraint to _margins, and then I'm going to add 0 to all of these by default. If safe area is available, it'll be set to the safe area, and that's what we want because we don't want that stack view to be under anything else because it contains our collection view, which are the cards. So let's add it. It's going to shift it like that. Also, I want you to notice that the alignment is center, and that means that it's centering all of the elements inside of that stack view to the center. Now this is fine for the label for now, and the collection view as well. But one thing to know about centering versus the other option you can also do is fill. Fill will actually stretch the elements inside so that it fills up the entire width of that vertical stack view. When you choose center, it will center it, but there will be no width applied to those elements. It's going to rely on whatever inherent width those elements are. I want to make sure that the collection view knows exactly how wide it should be so that it knows how to lay out the cards. Because if I don't specify the width, then you may get some weird layout behavior. You may ask before, we didn't specify width for the collection view either, but the case before was that we were anchoring the left edge of the collection view to the left side of the screen and the right edge of the collection view to the right side of the screen. Now, since we've put it into a stack view, those auto layout constraints are gone. So one easy thing to do is just to make the collection view the same width as the stack view, because we've already indicated on the stack view that the stack view edges are on the left and right edges of the screen. So all I need to do is make the collection view and the stack view the same width. Now there are two different ways you could do this. One is that you can hold down Control and click from your collection view to your stack view, and when you let go, you can just choose equal widths. So that's really easy to do. Another thing you could do is hold down Command and select both of them so that they're highlighted like this, and go down here to add new constraints and just choose equal widths. So you can do either or, that's the same thing. and then we should be pretty good. So for the label here, let's put in some sample text for now. I'm going to put time remaining. I'm just going to say 10. And then what we're going to do now is open up Assistant Editor view so that we can hook up that label and expose it to the view controller. So go ahead in Editor up here, Editor and Assistant, and you should be looking at viewcontroller.swift on the right hand side. And here I'm going to make a space and then hold down Control and add an IB outlet. I'm going to call this the timer label. All right, so now I have a reference to that label so that I can update it as the timer goes off. I'm going to do editor only now and go back to the view controller. Now at the very top, I'm going to declare a property up here. I'm going to call this the timer. Let's use lowercase so it doesn't conflict with the actual class name, which is a capital T timer. So this is going to be a data type of timer, and I'm going to make it an optional, which means that it's nil at first. In the view.load, however, I am going to set that timer variable. I'm going to get a timer with the duration that I want. So here, let's initialize the timer. So I'm going to say timer is equal to timer dot scheduled timer. There are a couple of different ones that you can choose actually. I want you to choose the one that has target and selector. So these two parameters will indicate when the timer elapses, when it's done, what method do you want to call. Selector is another name for method. You can think of it like that. And target will be the object that you want to call that method on. So I'm going to choose this one right here. Now the time interval is specified in seconds, but I want this to happen in milliseconds because I want to update the timer label every millisecond so that it's a little more high pressure for the person who's trying to flip cards when that timer is constantly running. So there are 1,000 milliseconds in 1 second. So I'm going to basically do that, which is going to be 0.001. So that is 1 millisecond expressed in terms of seconds. Now target is going to be self because I'm going to write that timer fire method in here. So the selector is going to be referencing a method that I create. Let me just write it here actually so that we can speak about it in more concrete terms. So let's use mark, and then let's call this timer methods, and then create a new method called timer fired. All right, and here I want to specify that whenever the timer elapses, at each millisecond, it should call the timer fired method of this view controller object. Now, in order to specify a method as a selector, you have to use a special syntax. You use this hashtag or pound symbol, whatever you want to call it, selector, and you can see autocomplete is going to allow you to just select this, but then you put in 2 rounded brackets, and inside you put the method name. So this is going to be timer fired. Now, you can count on Xcode giving you an error here, and we're going to take a look at this in a second, but first let me just talk about these two. So user info is going to allow you to specify some additional options. At this point, we're not going to do that. We're just going to put nil in there. Repeats is whether or not you want this timer to loop, right? After 1 millisecond has passed, and we definitely want that, so I'm going to put true in there. Now let's talk about this error that they're talking about here. So let me see if it's gonna give me that back. Well, if I press Command B, oh, there it is. So it says that argument of selector refers to an instance method, timer fired, that is not exposed to Objective-C. Add this special at Objective-C tag to expose this instance method to Objective-C. And so when you hit fix, you'll notice that it's going to add this special symbol in front of this method, and that's just going to allow the selector and the timer to grab this method. Now, if you weren't aware, Objective-C used to be the only language you used to write iOS apps, and then they came up with Swift. Well, there's all of this legacy code still written in Objective-C, and when they created Swift, they made it so that you can use those Objective-C libraries and code. So at this point, some of the classes that you're using here, and even some of them in UIKit, they are underlying, under the hood, is Objective-C. And so something with the timer and something with the selector uses Objective-C under the hood. And so this is kind of a way to expose our Swift method to be able to interop and play nice with something to do with the timer or selector. Now, the good thing about this is that you never really have to worry about that tag, this Objective-C tag. Whenever you need it and you don't specify it, Xcode is just going to warn you, and then you can go ahead and just click fix, and it's going to add it wherever it needs. Now, as far as what I've worked with, the only time I've needed to use this is with specifying methods as a selector, as a parameter, where a method needs to get called. So using the special selector syntax. So just an FYI for you there. Now, what do we want to do inside this timer fired method? Well, we want to give the user a specified amount of time to solve the puzzle, right? We're going to indicate that up here. So I'm going to call this milliseconds, and this is going to be, I'm going to express it in terms of integers so it's easier to work with. So let's say 10 seconds. 10 seconds would be 10 times 1,000, right? That would give us the equivalent in milliseconds. So I'm just going to write 10 times 1,000 so it's easy to see that this is 10 seconds. Essentially, this will be 10,000 in this variable. Each time that timer fires, I want to decrement the counter, update the label, stop the timer if it reaches 0, and then check if the user has cleared all the cards or all the pairs. So decrementing the counter is easy. We're going to do milliseconds minus equals 1, and that's just going to take off 1 millisecond. Now, updating the label is going to require us to express the amount of milliseconds in seconds, because as far as the user is concerned, it's easier to look at the number of seconds involved rather than milliseconds. But however, I do want to show like it might be 10 seconds dot something milliseconds, and it's going to be counting furiously. So let me show you what I mean here. In order to calculate the number of seconds, we would say let seconds equal milliseconds divided by 1,000. However, I want to make sure that this has the decimal places that I want. I don't want it to round it to the nearest integer. And so just to make sure, we can explicitly declare this as a double. And we can also divide it by 1,000.0. So when it's doing math like that, let me see what it's complaining about, int and double. So yeah, so we can actually cast milliseconds as a double like this, right? And then we're doing math on 2 doubles instead. So we're turning this into a decimal, we're dividing by a decimal, and we're going to get back a decimal right here. So next we're going to update the timer label. So timer label.text is equal to, and we're going to create a brand new string here. Now the string has an initializer method where it lets you specify a specific format, because what I want to do is round it to the 2 decimal places. And so if we choose format here, this one right here, where we can specify an argument, the format is going to be, let's see here, the percentage sign stands for wildcard. So whatever I put here is going to be substituted into the percentage sign. But in order to specify that I want this number to be 2 decimal places, we used decimal and then 2f. So the argument is going to be what I declared up here. It's going to be our seconds, right? And then we are going to get that expressed in 2 decimal places. So I'm going to update that. Now, stop if the timer reaches 0, all we need to do is check if milliseconds is equal to 0, then we're going to stop the timer. So in order to stop the timer, we need to call the invalidate method on the timer. So let's do timer.invalidate. That's going to stop the timer. I'm going to write a to-do here. We also want to check if the user has cleared all the pairs, right? So we're going to do that right after the timer reaches 0. But I want to run the app now and just to see our timer in action. All right, so you can see there, it's running with the 2 decimal places. That's what I meant by showing the milliseconds, but expressed in terms of seconds. Now it reaches 0. I actually want to turn that text red, and we also lost the whole time remaining part of it. So let's add that, time remaining. And then when it reaches 0, let's change the timer label dot text color is equal to UI color dot red. So let's give that a try. All right, now I don't know if you'll notice, but this timer label is actually slightly wobbling left and right. Well, what's actually happening there? You know, as it's changing, it's shifting left and right. The reason is because the numbers have slightly different widths, and so when the timer is counting down, for the fatter numbers, the label is wider. For the skinnier numbers, like the ones, the timer label is actually a little less wide because we haven't explicitly specified a width for that label. So each time the width changes, it's trying to center it, and so that you get that little wobbling as the numbers change. So in order to fix this, what we're going to have to do is just manually specify a hard-coded width for this label that we know won't accidentally crop out something. So based on my own testing, I've found that 200 works for this label. So I'm actually going to just put a width of 200 in there. Add that constraint for the label right there. And I'm going to specify that the alignment for the label is going to be centered. You know what, that actually, I might have to left align it, to be honest. So let me just give that a try and see what happens. Yeah, so we still get that issue because it's always trying to center align the text even though the label is a fixed width. So essentially what I have to do is I have to left align the label, but I am going to probably not do 200 because 200 I think is too wide and it's going to look offset. So let me show you what I mean. So I've left aligned it. You can see that the label doesn't wobble anymore, but it's not quite in the center, right? Because the label is wider than it needs to be. So I'm going to modify this width constraint. I think 150 is actually the appropriate size. Nope, definitely not. So was it 190? Let's try 190. So that's a little better. I think that's going to do for now. All right, so we've got our label there. The next thing we want to do is going back to here, check if the user has cleared all the pairs. We want to basically see if the user has won or not, right? So we are going to do that in a method. We're not going to do that here because there's a couple of places where we need to check if the user has won. So I'm going to check for game end. I'm just going to write this method here. This is a method that we're going to declare down below in the game logic section. Check for game end. And this is when the timer reaches 0. We want to check if the game has ended. There's another place we want to check whether or not the game has ended, and that is when the user matches a card. Right down here in the check for match method, when it's a match, we want to see, well, was that the last pair? And so we will also want to check for game end. Okay, and now we actually have to write that method. So down here in the game logic section still, let's check for game end. And here's the general sort of thought process behind this. We're going to check if all the pairs, we're going to check if there's any card that is unmatched, right? And we can do that by just checking if any of the 16 cards has this set to false, right? That means that there is a card on the grid that is not matched yet. So here's how we're going to do this. Let's go back to the viewController.swift, and what we're going to do is declare a flag up here. Let's say var has 1 is equal to true, right? And so the idea is that we're going to assume that the user has 1 and that he or she has matched all of the pairs, and then we're going to cycle through all of the cards in our cards array, and we're going to check that is matched property. And if there is even one card where is matched is false, then we know that the user hasn't matched all the cards yet, and that we're going to change this has 1 flag to false. And so that's how we're going to find out. So now, let me write that logic here. Assume the user has 1, loop through all the cards to see if all of them are matched. So we're going to say for card in cards array that contains each of our cards, right? And we're going to check the property is matched, right? If is matched is equal to false, then we've found a card that is unmatched. So we're going to say has 1 is equal to false, and then we are going to break out of this loop because that's all we need. That's the smoking gun. The user hasn't won yet. So we're going to use the break keyword to kill the loop, and we don't have to go through the rest of the cards array. So in here, we basically check that flag. If has 1 is equal to true, then user has 1, else user hasn't won yet. And one note I want to make on this sort of redundant code, because in an if statement, all you need to do is actually to do that, right? Since this is a Boolean variable, this represents true or false. We don't have to test it for true. But sometimes I do like to write that code, especially if I'm teaching beginners, because it's more clear for them. Over time, once you get more into the intermediate level, or you're really used to reading Swift code, this will be no problem to you. You'll see that this was Boolean up here, and you'll know that, you know, it's going to come into here if has 1 is true, and it's going to come in here if has 1 is false. But I'm going to leave it in there now just so it's more clear to you. Now, if the user has 1, we're going to want to show an alert. And by alert, I just mean a pop-up dialog, because that's what the iOS system calls an alert. And if the user hasn't won that yet, check if there's any time left. Because if there is time left and we don't want to do anything, the user still has time to match pairs. However, if there's no more time left, then we want to definitely show an alert and say that you're out of time, sorry you didn't win, or something like that. Since we need to show an alert here and here, I don't want to repeat the code, because the only thing that's different is the messaging. And so I'm going to create a different method down here. I'm going to call this show alert, and I'm going to accept 2 parameters here, title and message, because those are the 2 things that you can specify in an alert. And let's take a look at what that code looks like. So the actual alert class is UI alert controller. So we're going to say let alert equal to a new UI alert controller. And actually I pressed that too quickly, because there is an initializer method where we can pass in that title and message. So I'm just going to pass in the parameters from this function here into the title and message parameters. And then for the preferred style, I'm going to choose alert. Action sheet is that sheet that slides up from the bottom of the screen. Alert is those standard iOS pop-ups that you see. Now, in order to present this alert, all we have to do is to use the present method of the view controller. So the view controller is going to take that UI alert controller and show it. So here we need to just pass in the alert, and we can say animated is true and completion is nil. Now let's go ahead and show this alert. So back here, if the user has won, we're going to call show alert, and our title is going to be congratulations, you've won the game. Otherwise, we're going to test if there's any time left by checking milliseconds. If milliseconds is less than or equal to 0, or you can just do equals 0, but if there's a case where it's less than 0, then this will capture that too. We're going to show alert and say time's up. Sorry, better luck next time. All right, so let's try this out. I don't think I can actually finish the game in 10 seconds, which is the amount of time we've gotten, but at least we can test the other message. So this is actually a little harder than it looks. All right, time's up, better luck next time. Now, you can see that the user can't really take any action on this pop-up, and sometimes that's what you want, but other times you want to provide some actions, right? And in order to provide some actions in an alert, you have to add the buttons to that UI alert controller. So let me show you that. Let alert action equals UI alert action. That's actually a class. And this represents one button that we're going to put in the dialog. So it's got a initializer where we can pass in the title for that button. I'm just going to put OK. The style is going to be default. Destructive is going to be red. I think cancel is red as well. So we're going to use default, and handler is the code that you want to run when the user taps on the button. So in our case right now, I just want to let the user dismiss it, so I'm going to put nil there. But just because we've created this UI alert action object, that doesn't mean there will be a button. We actually have to add this button to the alert itself. So let's say alert.add action, and we pass in the alert action. Now, actually, this constant is not very descriptive. I'm going to call this the OK action. So that's more descriptive of exactly what it is. Add a button for the user to dismiss it. Create the alert. And this one is show the alert. All right, so now we can attempt this again and obviously fail again because I can't do this in the amount of time that I've given myself. All right, so there you go. There's an OK button. And I'm not going to test the case of winning because I'm pretty sure that it works. But you definitely should. I don't want to draw this video out too long. Give yourself more time up here and then test it out, and we should be able to see the other alert again as well, I mean, right up here. Now, one of the things you might notice is that, let me just restart this game so I can show you, is that when the timer is running and you scroll, the timer stops, right? And if I let go of scrolling the UI view, the timer runs again. So what's happening over there? Well, I have to explain some of the mechanics of how the timer works. So what happens is when you schedule a timer, it gets scheduled into something called a run loop. And you can think of a run loop as something that just dictates when different elements should be executed or should be executing. So when you schedule a timer with this line of code right here, it gets scheduled into the main run loop. But the thing is, the task that is in charge of updating the user interface is also on the main run loop. So when you're scrolling and it's busy updating the cells and it's asking the UI view controller for what cell it should display, and it should be configuring the cell before it gets displayed, that work is blocking the timer from executing and running. And so what we need to do is essentially move that timer into a different run loop, one that is more suitable for what we need the timer to do, which is kind of like a background task almost, right? Regardless of what's happening on the front end, we always want that timer to be running and not stop. And the way we can do this is actually there is a run loop class, which we can use to modify what gets put on which run loop. So we're going to access the main run loop and we're going to call the add method. There is actually one here for the timer. So we are going to add our timer. We're going to have to force unwrap it because remember, timer is an optional property, right? So we're going to force unwrap it to get the actual timer object. And for the mode, there are a couple of different modes that we could do. If you hit dot, you're going to see there's common, there's default, and there's tracking. So you can take a read at what the descriptions are, but I can tell you that the one we want to use is common. So let's go ahead and set that, and let's run the application now. And that fixes the problem. So there you have it. You learned how to add timers to fire at specific intervals. You learned how to hook up a function so that that function can occur when the interval fires. You learned how to create and show alerts to the user and how to add alert actions to that pop-up so that the user can take action on that alert. All right, so with that, we are nearly done. I'll see you in the next lesson.